Okay, hello again. This is the third video in the radicals unit and third video overall. I figured out that I could save time by actually writing the title before I start recording. So I am learning things too. Okay, we're going to add and subtract radicals now. The main concept of adding and subtracting radicals is quite simple. So the first two or three examples are going to be, I think, pretty easy to understand. But then when you start applying this on a different level, it can get a little complex. But the first two or three examples are going to be easy. So when you're adding and subtracting radicals, just remember one thing. They add and subtract just like variables. And what I mean is, when you add and subtract variables, let's say 3x plus 2x, all you do is add the coefficients, right? You don't do anything to that x, it's still x, because if you have 3x's and you add 2x's, you now have 5x's, right? You don't have 5x squared, you don't have 5 times 2x, you just have 5x's. And if you're subtracting, you are only going to subtract the coefficients, right? 3x minus 2x, you now have 1x. So when you're adding and subtracting radicals, the radical acts just like the variable does in these two examples. So if I have 4 rad 5s and I add 9 rad 5s to it, I now have a total of 13 rad 5s. The rad 5 stays the way it is. In this example, I have 3 rads. I have 2 rad 3, I'm subtracting 8 rad 2, and then I'm adding 12 rad 3. Well, these 3 rads are not all the same. Two of them are a rad 3 type, and one of them is a rad 2 type. So this is no different than if I had 2x minus 8y plus 12x, right? You would combine like terms by combining the 2x and the 12x. You would not combine them with the 8y in any way. So the same goes for these rads. You will combine the 2 rad 3 and the 12 rad 3 in the same manner that we combined 4 rad 5 and 9 rad 5 in the first example, but you cannot combine 2 rad 3 and 12 rad 3 with 8 rad 2 because they're as different as x and y. So I have a total of 14 rad 3 and then minus 8 rad 2. And that is as simple as that expression gets. There is nothing we can do with that to simplify it further. Okay, so those first two examples were quite easy. I should probably never say that because it's not easy for everybody. But now we're taking it up a notch. As you can see, these rads are not the same type. Or are they? On the surface, 18 and 8 are definitely different. But rad 18 and rad 8, we must investigate a little further to see if they really, really are different. So based on the first two videos, you should have a feeling that, yes, we can simplify rad 18 now. And I know in at least one example we've already simplified rad 8. So let's see what happens when we simplify both. 18 is 9 times 2, and 8 is 4 times 2. So the first rad simplifies to 3 rad 2, and you probably get the idea of what's going to happen next. The second rad becomes 2 rad 2, and now we see that rad 18 and rad 8 actually are the same type of rad. They were just in disguise, as many things in math are. They were in disguise, and now it's revealed that they are the same type, which means, yes, we can add them. Okay. I'm going to do another one of the same, sort of the same level as the example we just did, except now we're subtracting. Okay, again, on the surface, they look like different rads. One is a rad 24, the other one is a rad 6. But if we simplify rad 24, I'm going to skip a step here. It becomes 2 rad 6, because it was rad 4 times 6. And now I have 2 rads of the same type, so I can subtract their coefficients. 2 minus 3 is -1, so negative rad 6. All right, we're going to take it up another notch by combining something we did several units ago, which is multiplying binomials. We did this in Unit 7 in the polynomials unit. So now I'm going to put these rads into binomials and multiply the binomials. So if you remember from your polynomials unit, if I have 2 binomials and I'm multiplying them, I go like this, right? AC plus AD plus BC plus BD, like that. So I'm going to do the same thing here. In this example, this is A, this is 3 rad 6, that whole thing is B. Another rad 2 is C, and then another 3 rad 6 is D. And be careful of the signs. This binomial has a plus, this binomial has a minus operation. Okay, so rad 2 times rad 2 is 2, no problem. Okay, rad 2, so now the next one is going to be, next term will be negative. Rad 2 times 3 rad 6. I'll write that out. I'll simplify it in a minute. And then, here we go, 3 rad 6 times rad 2. Looks familiar. And then finally, minus 3 rad 6 times 3 rad 6. Okay, now I got to do some simplifying. The 2, there's nothing I can do with that. This, yes, could be simplified, but look at what's right next to it. This, which is identical to that except for the sign. So this and this, the negative 3 rad 6 rad 2 and the positive 3 rad 6 rad 2, they are additive inverses, so when we add them, they're going to become 0. So I actually don't have to do anything there. I can just act like they're not there. And then here, minus this times this. The 3 times 3 becomes 9. The rad 6 times rad 6 becomes 6. So that's 2 minus 54, which is negative 52. Which looks a little suspicious to me. Yeah, that's correct. So we ended up with a totally rational answer in that case. Now some of you might have already noticed there's a shortcut we could have taken. If we go back to the original expression, and we'll see that this expression is in the form of a plus b, a minus b. And that should look familiar to you. A plus b times a minus b equals a squared minus b squared. So I can simply take my a, which in this case is rad 2, square it, take my b, which is 3 rad 6, square it, and subtract the 2, and that should also give me negative 52. Oh, that's wrong. So that's 2 minus, and this squared is 9 times 6, so that's, we know that's negative 52 again. So if we recognize that that was a difference of squares, we go straight from the given expression to this in one step, and then from this to this in 2, and then here we're there in 3 steps. Okay, and the final example is sort of along the same lines. I have a binomial squared. A binomial squared, and we've seen that before too. If I have a binomial squared, there's a pattern. That's a perfect squared trinomial pattern. A squared plus 2ab plus b squared. So if I recognize that, then I don't have to do the long drawn out foiling. By foiling I mean doing this and then writing that out and then simplifying that long expression. I can simply put this into this trinomial form straight. So since this is a and this is b, and my first term in the trinomial is a squared, then the first term will be 2 rad 5 squared, which is 20. My second term is supposed to be 2ab, so 2ab. And then my third term is supposed to be b squared. B is rad 3, so b squared is just 3. And then I combine my like terms. The 20 and the 3, they're definitely like terms. And then this, I'll just multiply together to get the second term, 4 rad 15, and we're done. Okay, if you recognize these patterns, in this case the perfect squared trinomial pattern, and in the previous example the difference of squares pattern, a plus b times a minus b to a squared minus b squared. That's great. It saves you time. If you don't recognize it right off, it doesn't matter. You can always FOIL and get there eventually. Okay, that concludes the third video for the first week of radicals. See you later.